we call HCl?
HCl is a strong acid because it releases high concentration of hydronium ions, H3O plus ions in solution on dissociating.
Okay. And what happens in the case of bases and alkali?
In the cases of bases and alkali, first of alkalis are soluble in water and they readily form and they dissociate into OH and H minus. On the other hand, bases are soluble in water but they only release OH minus and OH minus ions in solution.
Okay. In which
Hydroxyl.
cases the salt and water are formed? In the case of bases or in the case of alkali?
In the case when a base reacts with an acid, it forms a salt.
Okay. Be more particular towards the definition like a base reacts with hydronium ion of an acid, right? We know
Yes.
that a base is going to
Base
react with an acid, but
the
hmm,
hydroxyl ion of a base reacts with the hydronium ion of an acid to form
yeah,
salt.
to get salt and water. Okay. So can you name some alkali which are soluble in water?
NaCl, there's NaCl, MgCl,
There is a
FeCl.
salt, not salt. I asked you about
Okay,
bases.
sorry. You
Alkali.
said you said alkali.
Alkali.
Then FeOH whole twice, FeOH whole thrice, NaOH, KOH, etc.
Okay. In terms of basicity, we have already revised you this chapter, the monobasic, dibasic, and tribasic. So when I'm talking about the phosphoric acid, that is H3PO4, its basicity would be
3.
3. Okay. When we are talking about the carbonic acid, H2CO3, its basicity would be
3 I think.
no, H2CO3, 2.
Yes, 2.
Yeah. When we are talking about the acetic acid, its basicity would be
1.
1. Okay. Acetic acid, as you know, it has 4 hydrogen atoms, but it ionizes only in the aqueous solution. So that's why it is an weak alkali, a weak acid or a strong acid.
It is a weak acid
And why do we call acetic acid a weak acid?
because it releases less concentration of hydronium ion H3O plus ions in solution on dissociating,
How dissociating? Partially.
partially dissociating.
Yes. Okay. When we are talking about sulfuric acid, it is a strong acid. Why is it called a strong acid?
Because it releases high concentration of hydronium ion and soluble ionizes completely in the aqueous solution, and hence it releases high concentration of H3O plus ions.
Okay. When I'm talking about the concentrated alkali have higher percentage of
Water.
concentrated alkali, higher percentage of alkali, not water.
Yes, alkali.
Yeah, alkali. Okay. When I'm talking about the dilute acid, it is having low percentage of
Acid.
acid. Okay. You have to give the answer in terms of acid, not in terms of water. Okay. You will use the term aqueous solution, not water. Okay. Then we have to categorize the acidity of some bases. For example, if we have if we have any ferric hydroxide, which is water insoluble, it would have the acidity
3.
3. When we are talking about calcium hydroxide or copper hydroxide,
2.
2.
Acidity.
When we have ammonium hydroxide or potassium hydroxide,
1.
1. Okay. There was two theories given by the two scientists. The first theory is known as the Arrhenius theory. What does it say? That the acids are the substance which
Dissociate in aqueous solution to give H plus ions.
ions. Okay. Then we have the Bronsted-Lowry theory or Lonsted-Lowry theory. It states that the acids are what? Proton donors or acceptors?
Acids are proton donors and bases are proton acceptors. And when they dissociate, they release H plus ions and bases release hydroxyl ions, OH minus.
Okay. Can you give an example of the proton donor?
HCl,
HCl. And the base as a proton acceptor?
HNO3,
HNO3 is
KO,
not a base. HNO3, no. HNO3 is
uh,
nitric acid.
NH3,
NH3. NH3 is ammonia or ammonium.
ammonia.
Ammonia.
When
Okay.
it accepts two electrons, that is, it becomes NH4. It is known as ammonium.
Hmm. So water is a polar covalent molecule and exhibits charge separation. Do you agree with this statement?
Could you repeat?
The water is a polar covalent molecule and exhibits charge separation.
Yes, I agree.
How do you justify the term charge separation in water molecule?
By charge separation, we mean that when water molecule, hydrogen forms a slightly positive charge, while chlorine forms a slightly negative charge. That is, hydrogen
Oxygen.
is represented by delta positive and chlorine by delta negative. So in total,
Yes.
there is charge distribution between the whole molecule.
Yeah. Instead of oxygen, you told chlorine. It must be oxygen.
I told oxygen only.
No, no, you told chlorine. Okay. So how many lone pairs do the oxygen atom have?
One.
Oxygen have two lone pairs. Nitrogen has one.
When it forms hydroxyl ions, it has one.
No, like if we talk about H2O, so H2O have
So
two lone pairs.
then it has two lone pairs.
Yes, then it has two lone pairs. Are these pairs shared with any other atom?
These pairs are shared by one H atom.
No, the lone pairs are not shared because that's why we are calling
Lone
lone
pairs
pair because after
do not participate in the formation of the covalent molecule.
they do not share. If they are going to be shared, then they will be form coordinate bond, and oxygen does not form coordinate bond, water molecule. Okay, then we have the coordinate bond, which is formed between the atoms of the polar covalent molecule and the lone pair of the electrons. Okay, in terms of hydroxyl ions, the hydroxyl ions are formed in the acidic solution or the alkylic solution.
Alkylic solution.
Alkali. So the hydroxyl ion are the example of the proton acceptor or proton donors.
Proton acceptor.
Okay. So when a proton is released from the water, does it adds or subtracts to the lone pair?
It subtracts.
It adds because it is going
Yes,
to accept.
yes, it adds.
It adds. Okay. Then we have preparations of acids and bases from non-metals. So when we are preparing acids from non-metals, for example, if hydrogen is combining with oxygen, sorry, hydrogen is combining with chlorine, that is a non-metal. Chlorine is a non-metal. So it forms which acid?
HCl, hydrochloric acid.
HCl. Okay. And then sodium, which is a metal, combines with gases like oxygen. Metal combines with oxygen. It forms?
HNO3.
No, 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 no. When sodium combines with oxygen,
Acha, HO. It forms a
and
base.
it forms base,
Na2O.
that is Na2O. Yeah, basic oxide. Okay.
Sodium oxide.
Yeah, sodium oxide. Okay. The second preparation we learned from the acidic oxide. So, for example, if we talk about SO2, when it reacts with water, when it comes in contact with water, dissolve in water, it forms
H2SO3,
which
that
acid?
is sulfurous acid.
That is which acid?
Sulfurous again. Sulfurous.
Sulfurous. No, no,
Sulfurous.
sulfurous. Yeah.
Yes, sulfurous.
Okay. When SO3 reacts with comes in contact with water, it forms
H2SO4.
yeah, sulfuric
That is
acid.
sulfuric acid.
Hmm. In the case of basic oxide, when the basic oxide, if we take an example of sodium oxide reacting with water, forms base. What is the name of this
NaOH.
base?
Sodium.
NaOH. Okay. And if on the other hand, the reaction of the metals with directly with the water is considered as exothermic reaction. Why?
Because it releases heat during the formation of the base.
Yeah, it releases large amount of heat energy. Also, the hydrogen gas is released.
Yes.
Okay. Then we have the when non-metal is oxidized, that also forms the acid. Like when a non-metal sulfur is oxidized in the presence of nitric acid, like S plus HNO3. So here nitric acid is acting as an oxidizing agent. So it gives an acid which is known as the sulfuric acid, right? While on the other hand, the basis on decomposition gives salt. Okay. Then we are having the properties of acids and bases. The first property we know very well, that is the taste. The acids are sour and the bases are bitter. Secondly, the acids in categorization of the acid, we learn that the mineral acid, the HCl, HNO3, they are what? Highly corrosive in nature. On the other hand, bases like caustic alkalis, KOH and NaOH, they are also highly corrosive. Okay. Can you tell me that in terms of indicators, If we talk about the
In terms of
litmus, yeah.
in terms of indicator in acids, blue litmus paper turns red, and in bases, red litmus paper turns blue, and methyl orange in case of acid turns orange to, I think, pink in bases, and in
In
cases
pink in
of
acids.
pink in acids, and orange to
No, no,
colorless.
yellow.
Yeah, orange to yellow
No,
in terms of bases, and phenolphthalein remains colorless in acids, and phenolphthalein turns pink
yeah,
in case of bases.
yeah. Methyl orange, let me correct you. Methyl orange, in acid it turns pink, and in alkaline solution it turns yellow, not orange.
Yes.
Orange is its original color. Okay. When we talk about the chemical properties of acid, the first note, short note, comes from the neutralization reaction. What happens in the neutralization reaction? The acids react with.
Acid neutralize bases by reacting with the hydroxyl ions of the bases to form salt and water only.
Okay. Can you give me one example of the reaction?
Yes, Zn plus 2HCl gives us ZnCl2 plus H2, which is a
Okay.
salt, ZnCl2, and H2 is hydrogen gas.
Okay. When the active metals react with acids, they release which gas?
H2, hydrogen.
Hydrogen. If we talk about sodium carbonate, the gas which is released would be
CO2,
CO2. When we talk about sodium nitrate, NaNO3, the gas released would be
NO2.
NO2. Okay. Also, when sodium nitrate in the presence of an acid, sulfuric acid, H2SO4, is brought to less than 200 degrees Celsius temperature, then we get an acid. The name of this acid would be,
Nitric acid, it forms actually two acids, nitric acid and nitrous acid. Well, nitric acid is HNO3 and nitrous acid is HNO2. It is mentioned in, you see the reaction.
yeah. Okay. So, in the chemical properties of bases, we know that the alkalis they react with ammonium salts and it displaces. So, what is the cause of this displacement? Who
They
displaces the
release
whom?
ammonia gas, NH3.
No, you have to turn, just try to tell the answer in terms of the volatility. Like a less volatile base would replace the
Yes. A
volatile
less
base.
volatile base is a base, example NaOH, KOH, NH4OH. NH4OH is a weak base.
And
Uh,
in which case you will get the insoluble hydroxide when
when we have to in certain metallic salts when alkalis react with certain metallic salts such as salts of Cu or Fe, they precipitate out, they give precipitates on heating, hydroxides.
it is not soluble. So, can you tell me
uh,
the color change in the case of copper hydroxide?
Copper hydroxide, blue precipitate forms,
Yeah, it forms blue PPT. Then we have ferrous hydroxide. It forms reddish
reddish
brown.
brown PPT.
And the zinc hydroxide, the
Gelatinous white.
yeah, gelatinous white PPT. Okay. There is a term on page number 45 that is the heat of neutralization. That is the amount of heat which is liberated when an acid reacts with base, when it is completely neutralized. Since we cannot say it exothermic because the heat release could be is very small. So we have not called it exothermic reaction, we have named it as the heat of neutralization. Okay, then you have to learn certain uses, the name of the acids present in respective, some of the respective compounds, like cooking and pickling and eye washing, and also some of the bases which are present in. Okay, so tell me the base, some of the common example I'm asking you. In bases, which base is present in the manufacture of bleaching powder?
Bleaching powder, I think. Calcium hydroxide, I think.
Calcium hydroxide, as an antacid which is used to neutralize the acidity.
MgOH.
Yeah, magnesium hydroxide. In removing grease stains from clothes.
uh, Ammonium hydroxide,
Ammonium hydroxide.
NH2OH.
Yeah. Okay. Then we have baking powder, the very common example. The acid present in baking powder,
Tartaric acid.
tartric acid. Okay. In food preservation,
Ma'am, could you repeat?
food preservation,
Citric acid,
citric acid. Eye washing.
boric acid,
Okay. The last one we have cooking, very common.
acetic, acetic acid,
Uh,
vinegar, CH3COH.
vinegar. Hmm. So, what is the harmful effects of the acid rain? Any three
Acid
harmful effects?
acid rains have a lot of effect on the population and cause a lot of damage to fertilizers and crops, and they cause atmospheric pollutants such as SO2, and they have also have a large amount of acids present in them when they rain, such as H2SO4, H2SO3, and HNO2.
Okay. How does it affect particularly the soil? In two
It
points.
reduces soil fertility and destroy
And
marine life due to change in the pH environment. It causes a more acidic pH, that is the pH reduces,
hmm, pH, in terms of acidity, it increases the acidity of the soil because obviously it is an acid rain.
but the pH reduces, right?
The
If
pH
this is
reduces.
neutral, when we go from here, it reduces acidic
Yes.
gas.
Okay. So what the indicators indicate what the presence of?
In the presence of an acidic or basic medium, depending upon the given conditions, they produce certain colors or behaviors.
Okay. How would you define the ionic product of water?
The ionic product of water is the amount of hydroxyl ion, that is OH minus, and H3O plus ion, that is hydronium, and it releases, which is equal to 10 to the power of minus 7 into 10 to the power of minus 7, which is equal to 10 to the power of minus 14 at 25 degrees Celsius, which is known as the ionic product of water. It is represented by Kw.
Kn at the base W. Okay. So when the pH is less than 7, what do you call that solution? Acidic or basic or
Acidic.
neutral?
Acidic.
Acidic. When the pH is 7,
Neutral.
neutral. Distilled water is neutral. Does it
Ah,
contain
yes.
any
What?
ions in
Yes,
them?
yes, water is neutral. Distilled water is neutral.
Distilled water is neutral. Okay. The pH in the H in pH stands for.
The HNPA stands for the negative logarithm of the base 10 of hydrogen ion, that is equal to 1 upon log of hydrogen ion H plus, which is equal to minus, that is the anti-log of minus log 10 H plus, which is just 1.
Hmm. Okay. Why we should use the universal indicators and not the common acid-base indicators? Any 2 points to justify your statement?
Universal indicators are indicators which are a mixture of common organic and inorganic dyes and mixed with indicators. They are used in pH paper or in solution. They indicate different color for different amount of the different mediums or acidic or medium. For example, highly acidic solutions are represented by red, little acidic orange, and so on. Green to red acidic, green to violet basic. Similarly, common acid-base indicators are used for indicating acid and bases in a particular environment. Universal indicators are more friendly and easier to use as compared to common acid-base indicators.
Friendly and easier to use. Not understood.
Friendly in the sense like a highly acidic solution is represented by red in universal indicator. But in common acid-base solution, it would be just blue to red. We would not know if it is highly acidic or acid.
Hmm. Good. Okay. So what is the utility of the pH in dairies?
Utility of the pH, yes.
pH in dairies.
pH is, pH is used in agriculture perspectives also because certain crops such as the rice need a little bit
Yes,
of
the growth of
acid
the crops are
to
also
grow,
tested.
and acidic medium to grow, and sugarcane needs a neutral medium, while on the other hand, some crops such as wheat need a alkaline medium to grow. And it is also used in dairies, technologies, biomedicine, also in certain medical aspects also, so that the pH of urine or any things can be checked for diabetes or any other things.
Okay. Can you tell me the pH value of the human blood?
Human
Blood.
7.3, that is neutral.
7.3. And of seawater?
8.5 alkaline.
8.5. Dilute sulfuric acid? Dilute.
1.0.
1.2. The dilute. Sulfuric acid.
Yes, 1. Yes.
Okay. The acetic acid?
2.9.
If I would give you two acid, the pH of the two acids would be 3.5 and 1.0. Who would be more acidic?
1.0 would be more acidic because its pH value is less. That is, it
Then
would
the lesser the pH value, the more the solution will be acidic.
highly acidic. It will release more hydronium ions, that is H2 plus ions
Oh,
in solution.
okay. So till here we have studied till this in our chapter. Now we are going to start the salts today.
Salts is the last topic of this chapter.
Yeah, the salts are the last topic of this chapter. Then our A part would be complete. Then we would go towards the B part.
I would read this chapter today and we can have test tomorrow. Is that fine?
Yeah, that is also fine. Let me see how much the chapter is left. Yeah,
Not
we
much.
are. It
We
could
will
be
be able to
done.
complete it almost three class or two class. We will be able to complete these all things.
Today, I guess
Fine.
the salt portion will be completed, and today, I guess today or tomorrow also the salt portion can be taken. The salt
And then we can
portion.
have one revision also, then the test.
Then we can go towards our B part.
Yes. After
Okay.
that, the test
So
or B part.
first we'll have the test after completing the A part, and then we'll go towards B part because B part is small. It would take one class only.
Yes.
Okay, so we are going to start our salt today. So how we are going to define the salt? Like the acids we have defined, it contains hydrogen ion. The bases we have defined, it contains the hydroxyl ions. Now how we are going to define the salt? A salt is a compound which is formed by the partial, that is means incomplete or complete replacement of the hydrogen ion of an acid. As you know, in neutralization reaction, the salt is formed. That means an acid reacts with the base to give salt and water. So what is happening in this reaction? It is being replaced. For example, if I take an example of a base that is NaOH and I take an example of an acid that is H2SO4. So what is going to happen that this hydrogen, which hydrogen I'm talking about, the hydrogen which is associated with the acid, this hydrogen would be replaced where this hydrogen is the hydrogen ion present in the acid, right? So this is a replaceable hydrogen. We cannot replace the hydrogen of the bases, right? We would be replacing the hydrogen ion of the acid. So salts are formed is a compound which is formed by the partial or complete replacement of the hydrogen ion of an acid. And how we are going to replace it with the basic radical. So here the product formed will be NaHSO4 plus H2O. As you can see, still hydrogen is present in our product form. So here the replacement is incomplete, that is partially, right? There would be another example, same example, like if you take again NaOH and H2SO4. Now, if we again made this reaction to occur, then the hydrogen of ion of the acid would be replaced with the basic radical, and now the reaction would be Na2SO4 plus H2O. Now, in this case, as you can see, there is no hydrogen ion present towards the product. It means what is happening here? That is the complete replacement of what? Of hydrogen ion from the acid. Here you can see the replacement was incomplete, so it is the partial replacement of the hydrogen ion from the acid. So similarly, the sodium hydroxide forms two kinds of bases, two kinds of salt. Here the name of the salt will be sodium bisulfate and the name of this will be sodium sulfate. So the both are the salt present.
Mixed salts, highly complex salts, and isomerism salts are those concepts are not there in our syllabus, right?
No, isomerism is not in your this part. It is in your organic chemistry,
It
not
is
in this part.
in one book it was there like one salt have the same structure and same formula, different I think
Yes.
chemical something like that.
Yes, yes. In the case of isomerism, your formula would remain same, but your structure would be different. In the organic chemistry we study, not in this chemistry, like the particular chemistry we are studying. This is not the organic. This is not the hydrocarbons. We basically study isomerism in hydrocarbons.
Ma'am,
As you can see,
and
it is hydro. Mhm.
ma'am, these both reactions you have taken the products are same. I mean, sorry, the reactant same. How is the reaction? How are the products different each time? What is the difference in condition of the two reactions which are provided?
There is not any particular condition in both the reaction. The basic criteria we are following, that the taking sodium hydroxide as a base and sulfuric acid as an acid, it forms two kinds of salt. Since it forms two kinds of salt, that's why the explanation is there that it is forming two kinds of salt. That is why it is forming the partial and the complete replacement. As you can see above the arrow, we have not given any particular temperature also. No particular condition has been given to you, right? So sodium hydroxide with an acid forms particularly the two kinds of salt. If you would take the potassium hydroxide, then it would not happen in the case of potassium hydroxide, because sodium being an active metal and forming NaOH, right, which is an active base, an alkali also.
Ma'am, but what has caused the difference in the reaction? If the reactants are same, environments are same, then the product should be same.
Uh, No, you're asking me about the conditions. What is happening in both the conditions? Which conditions we have been given to us? Okay. The condition in the first case, as you can see, wherever partial replacement of a hydrogen ion is taking place, here the temperature is above 200 degrees Celsius. This you will study in the second heading that is in given to you, types of salts. So in the first case, the temperature is kept above 200 degrees Celsius. And in the second case, the temperature is kept below 200 degrees Celsius. This is the condition we have been given to you. Here it is not been mentioned in this particular topic. In the second heading, you would be learning. So I just told you beforehand that what was the condition. Okay. So also you can define salt in another way. That one definition we have learned, that a salt is a compound which is formed by the partial or the incomplete replacement of the hydrogen ion of an acid with the basic radical. This is the first definition we read. The second definition, a salt can be an ionic compound. It dissociates to give the positive ion other than hydrogen. For example, if I take an example of a salt, that is NaCl. If I break it under an aqueous solution, it will form Na plus and Cl minus. Now, as you can see, a salt we have defined as an ionic compound. It is dissociating to give the positive ion and the negative ion, but other than hydrogen, right? So this is the another definition. Also, the negative ion we are having is not the hydroxyl ion, but other negative ion. So this is the another definition. So in exam, you can write this definition also and the other definition also. Both the definitions are appropriate, but try to mention the definition in terms of partial or complete replacement of the hydrogen ion. Then the next heading is we are going to study about the types of salt, right? The acid salt and the basic salt. As you can see, in the above example, we have formed the two kinds of salt, right? The first one was the partial replacement of the hydrogen ion, and the second one was the complete replacement of the hydrogen ion, right? So, from the above example, the NaHSO4 would be considered as an acid salt. And why we are considering this as an acid salt? Because it is formed by the partial replacement of the hydrogen ion, and hydrogen ion of what? Of an acid molecule with the basic radical, right? So, in this case, as you can see, only the one hydrogen ion is formed, so this is an acid salt, right? And how they are prepared? In this case, the preparation is done by taking the amount of base which is insufficient. Incomplete partial means that something is incomplete. So what is that which is leading to the incomplete or partial replacement? That is the insufficient amount of base we are taking for the neutralization acid. So the first characteristics you know very well, that was the temperature. The temperature was leading to the partial and the complete replacement. Now the second characteristic of this reaction being an acid salt is that we have taken an insufficient amount of base, and that's why the product formed is the incomplete or the partial replacement of the hydrogen ion. When talking about in terms of the basic salt, the Na2SO4 is called the basic salt. Why we are calling it a basic salt? The first reason, that it is formed by the complete replacement of the hydrogen ion of an acid with the basic radical. The first point. Second point, as you can see that in H2SO4, both the hydrogen ion has been replaced. That's why in the product we cannot see any hydrogen ion here. It means that the product form has completely replaced the hydrogen ion, and so it is called a normal salt, right? Thirdly, we can see that there is no incomplete or the partial replacement of the hydrogen ion. In the basic salt, there is complete replacement of the hydrogen ion. It means that the amount of base we have taken to neutralize an acid is very much sufficient, that all of the hydrogen of an acid has been neutralized, has been used up with the base, so that the product formed does not contain any hydrogen ion. Have you understood the acid salt and the normal salt? Let me summarize you once again.
Ma'am, could you
The acid
just tell the acid difference between acid salt and normal salt?
Yes. Firstly, you have to consider the two reaction which has been given to you. That is sodium hydroxide reacting with sulfuric acid. So in one case we are getting NaHSO4 and the other case we are getting Na2SO4. Right? They both are salt we know very well because at the suffix SO4 is present. Now, how we are going to categorize it as an acid salt or the normal salt? So the acid salt is formed by the partial replacement. As you can see, this is a kind of a neutralization reaction. The acid is reacting with the base. So obviously this is an example of the neutralization reaction. So what is being neutralized? The neutralization which is happening in the reaction is the reaction between the hydrogen ion of an acid. The hydrogen ion of an acid is being neutralized with the base. But still we can see in the product we have one hydrogen ion present. It means that the replacement has not been done completely. Replacement of what? The hydrogen ion of an acid. So that's why we are calling it an acid salt, because the replacement of the hydrogen ion of an acid is partial. That is incomplete. And why it is incomplete? Because the amount of base we have taken, NaOH, is insufficient, that it is not able to neutralize the hydrogen ion of the acid. The 2 points. Cleared?
Yes, ma'am.
In the case of basic salt, as you can see, the same conditions have been given, but the product form is Na2SO4, means that no hydrogen ion is present in the product. What does that mean? That it means that the all the hydrogen ions of the acid has been neutralized by the base. It means the base we have taken was present in the sufficient amount so that it has neutralized all the hydrogen ion of the acid. Right? So in short, we have learned about the 2 points. The first one, acid salt is formed by the partial replacement and the normal salt is formed by the complete replacement. And what is that is leading to the partial replacement is the insufficient amount of base which is taken for the neutralization. And in normal salt, it is formed when we have taken the base in a sufficient quantity. Thirdly, as you can see, the acid salt contains a replaceable hydrogen in the product, while the basic salt, it does not contain any replaceable hydrogen in its product form. So, since it contains the hydrogen ions in its acidic in its salt form, it means that it must have certain properties of an acid, right? Since we have Na2SO4, it does not contain any hydrogen ion present in the salt. It means that it would not possess any kind of properties of an acid. Right? So these are the 4 points. In page number 48, you have been given some examples of the acid salts and some examples of the normal salt. As you can see, this is HNO3, that is the nitric acid. Since acid salt is not formed, because since acid contains only one replaceable hydrogen, we have to notice that. It means that the basicity would be 1. In every case, you can see in the starting 3 cases, they all have the basicity 1, HNO3, HCl, and CH3COOH. Considering coming down the series, we can see the carbonic acid, the sulfurous acid, the sulfuric and the phosphoric acid. As you can see, when we would be reacting these with an acid, the product form would contain only the one replaceable hydrogen ion in the product form. So left hand side holds the acids and the right hand side holds the product, that is the acid salt. And as you can see in all the acid salts example, only one hydrogen is replaceable, like NaHCO3, NaHSO3, NaHSO4. Only one hydrogen is being replaceable. Considering of the
Excuse
normal
me.
salts, as you can see,
Ma'am, the basicity of an acid is the number of hydronium ion it releases, right?
the no, in when we talk in terms of acids, we take basicity, and when we talk in terms of bases, we take acidity
Yes, I'm that only telling the basicity of an acid is the number of hydronium ions it releases, right, per molecule.
per molecule. Yes,
Ma'am, so both HCl and CH3COH release one molecule, one H3O hydronium ion per molecule of their acid. They both have
they are
basicity.
they would not be releasing the hydronium ion, they would release hydrogen ion. They all are acids.
Yes, ma'am. I'm telling about the acids only. So why is HCl
Yes.
stronger than CH3COH? acidic acid, even though their basicity is same?
Because the it does not depends on the basicity, it depends on the strength. Strength means when we talk about the concentration, the concentration means the concentrated one or the dilute one. When we talk about HNO3 and acetic acid, we would consider the nitric acid or the HCl to be the strong acid, right? And the acetic acid would be considered as a weak acid, right? What is the reason for that? That we are calling HCl a strong acid and acetic acid a weak acid. Because from this definition, as you can see, when we have learned, the strong acid and the weak acid are categorized on the basis of the concentration of the hydronium ions and not over the acidity or basicity of a solution, right? So when we are talking about the acetic acid, we are calling it a weak acid because it is dissociating partially and it is producing lower concentration of hydrogen ion, not one hydrogen ion. Understood? We would be referring to the concentration and not the number of ions.
Concentration basically means not number.
Yes, concentration is not number. For example, when we were talking about the acidity, then we can clearly see that the basicity was 1, 2, and 3. But when we talk about the strength has particular unit, that is moles per liter. It has a particular unit. The when we talk about the concentration. Okay, so further we were talking about the salt. So in salt we have read about the acid and normal salt. The acid salt contains the partial replacement. The normal salt contains the complete replacement of the hydrogen ion of an acid. Right? As you can see in the product, this is NaHSO4. It contains one replaceable hydrogen ion, and in normal salt it does not contain any hydrogen ion. It means that the acid salt would possess certain properties of an acid, and the normal salts would not be possessing any properties of an acid. And what is the reason that it is leading to the partial replacement is the insufficient amount of base taken. In the second property, you can see in preparation, it is formed by the amount of base is taken, which is insufficient for neutralization. And in the normal salt, the quantity of base taken is quite sufficient so that it has neutralized all the acids of the all the hydrogen ion of the acid, leading to no hydrogen ion in the normal salt. Okay, talking towards our next category is the basic salt, double, mixed, and complex salt. Right. The basic salt, it is formed by the partial replacement. The definition of salt would remain same, that it is formed by the replacement of the hydrogen ion. What would be adding would be the preparation. Like for example, the basic salt is prepared by the partial replacement of the hydroxyl radicals. And right now we were studying about the hydrogen ion. Right. Now, since it is a basic salt, it would be having hydroxyl ions present in it. So the basic salt is a salt which is formed by the partial replacement of the hydroxyl radical, which can be a diabasic, acidic, or it can be a triacidic. For example, for example, we have taken is copper, CuOHNO3. Now, as you can see, it is a basic copper nitrate, CuNO3, but it is having OH in between. That's why it is a basic salt because it does not have any acidic radical H plus. It is having the basic radical OH. And what is happening is that it would be replacing the OH would be replacing the acidic ions of an acid. Right. Similarly, as you can see, copper chloride, basic copper chloride. The negative ion, that is the hydroxyl ion, would be replacing the ions of an acid. This is the product form, right? They don't find any hydrogen ion in this case. You would be asking that where is the hydrogen ion in the formula? That would be replacing. So this is the product form. Okay. Then we have the double salt. As the name suggests, the double salt, which is formed by mixing the saturated solution of two simple salt. Here the word saturated has been given to you. So what do you understand by the term saturation? You might have studied the saturated solution.
When a solution is cannot dissolve any more of the solvent solute.
Yeah. So the double salt is formed by mixing the saturated solutions of two simple salts. Right. For example, two simple salt which are chemically combined. For example, if we have taken alum, alum is the potash alum. In the formula of this, as you can see, potassium sulfate and aluminium sulfate. They both are the salts and they both are the kinds of two simple salt. As you can see, in both the salts, no hydrogen ion is present, right? So we cannot call it a acid salt, right? So they both are the kinds of simple salt. And as you can see, dot H2O has been given. This particular dot H2O denotes that it is formed in the crystalline form. right? Then you have an example of the ferrous ammonium sulfate, very important, the potash alum and more salt, always asked in the paper. And also the formula with the name of the two salts which has been taken, right? So here the two salts taken is potassium sulfate and aluminium sulfate. In the case of more salt in class 11th and 12th, you would be doing the experiment with the more salt, studying the titration. So in more, the formula of the more salt is ferrous ammonium sulfate. That is ferrous ammonium sulfate, as you can see. This is the ammonium sulfate and this is the ferrous sulfate, right? Here these two are the simple salts, two simple salts. Then you have the mixed salt. Mixed salts, there is no general method to prepare the mixed salt, but it contains two or more basic radical. Basic radical, for example, if we talk about sodium potassium carbonate, that is NaKCO3, and when it would be dissociating in the ions, the Na would acquire the positive charge, K would acquire a positive charge being a metal, and CO3 would acquire a negative charge being a non-metal, right? So this is, we are talking about the basic radical. The radicals generally mean the ions. So as you can see, the sodium and potassium would be dissociating as the ions. In the second example, bleaching powder, that is calcium oxychloride. The name of the salt is calcium oxychloride, right? CaOCl2. Now in this case, what are the two basic radicals? As you can see, the Ca would be give positive charge, right? So this would be not any acidic radical. Then we coming toward this side, OCl and Cl, they both will give the negative ion, right? The name of this particular is calcium oxychloride. Then at last you have the complex salt. Complex salt is formed by mixing the saturated solution of two simple salts. Like for example, the one is the simple ion and other is the complex ion. For example, if you take the example of sodium silver cyanide. So as you can see, this complex salt requires a bracket to write its name. No other, and also considering of the bracket, as you can see, it is a square bracket here, right? And in the above case, in mixed salt, as you can see, it is the normal bracket, right? So this square bracket holds a particular significance. So this is the potassium mercuric iodide.
Ma'am,
Yes,
in under potassium mercuric iodide, it is written it is used as a Nestle's reagent used for testing ammonia gas. What is the meaning of Nestle's reagent?
the it is for when we say this CaOCl2, it means it is calcium oxychloride and its other name is bleaching powder. Similarly, K2HgI4 is known as a Nestler reagent. It is used for testing the presence of ammonia gas. You can call, instead of calling this long name like potassium mercuric iodide, we call it the Nestler's reagent. Okay, it is a bottle and it is used to test the presence of the ammonia gas. Ammonia gas is highly pungent in smell. मतलब खांसी आती है उस smell से. So in potassium mercuric iodide K2HgI4, as you can see, a simple ion would be there and a complex ion. So simple means the K plus, that is the simple ion. Complex means the portion inside the bracket, Hgi4 minus. Obviously, the first would be positive and the other would be negative. That's why they are holding together. Secondly, talking about the sodium zincate, sodium means Na2ZnO2. This particular formula will come throughout your chemistry reading. Sodium zincate, Na2ZnO2. So here, what are the two ions? The first would be the simple ion, that is Na plus, and second would be the complex ion, that is ZnO2 minus. Right? You cannot break it according to your convenience, like Na plus and Zn plus and O2 minus. No. Then last one is the copper tetraamine copper sulfate. As you can see the naming, let me explain you. Tetraamine. So tetra means four, right? Amine means ammonia. So here as you can see, four means tetra. And what is four? It is the ammonium ion. So tetraamine, this is the copper, and SO4 is the sulfate. Right? So first we have the first, while writing the name, we have taken from the center. Then talking from after the center, we have taken metal, and then the outside bracket one. Right? We would be following this order. Firstly, the central metal, central atom, then the metal, and followed by a non-metal. Understood the all kinds of salt?
Yes, ma'am.
Okay, let me just have 2 minutes for you to revise this salt because, okay, let me ask, can you tell me the definition of the salt without looking?
A salt is a compound formed. Salt is a compound is formed when the H plus ions of a acid are replaced by a by another ion, and salt when dissociates it dissociates into a positive ion other than hydronium ion and negative ion other than hydroxyl ion.
Okay, so when you're talking about the replacement of the hydrogen ion, it is replacing with what?
It
By
is it is replacing with another positive ion, just say like Na plus in
like a
NaCl,
metallic ion. Hmm. Okay.
G plus in MgCl, and NH4 plus in NH4Cl.
Okay. Give four reasons to justify that why sodium bisulfate is an example of an acid salt.
Sodium bisulfate is an example of.
An acid salt. NaHSO4 is an example of an acid salt. Give four reasons to justify your statement.
Yes, it contains hydrogen ions. It contains one replaceable hydrogen ion. It exhibits some properties of an acid. It
Hmm.
properties of an acid. It is formed due to when the base is
Insufficient.
insufficient, and the
When the
large.
base is taken insufficient quantity amount.
Yes.
Okay.
uh,
And also it would exhibit all the properties of
Acid.
acid. Okay. So when you are taken sodium hydroxide and sulfuric acid, which quantity you have taken insufficient?
The base NaOH.
NaOH. Okay. When we are talking about the normal salt, so sodium sulfate, Na2SO4 is called the normal salt, right? So it is formed by the complete replacement of the hydrogen ion. As you can see in Na2SO4, there is no hydrogen ion present. So we are calling it this kind of replacement as a normal salt product. Why we are calling it as a normal salt and not the acidic salt?
Because it does not contain any hydrogen ion replaceable.
Replacement. Hmm.
It does not have properties of an acid, and it is prepared in sufficient base.
Base. Okay. So talking in terms of classification, we have the basic salt. So the definition of basic salt, it is formed by the basic salts are formed by the partial replacement or the complete replacement.
It is formed by the partial replacement of hydroxyl radicals of a diacidic or triacidic base when an
Yes.
acid reacts with it.
Okay. So when you have taken the copper, basic copper nitrate, so what is the cation which is present here?
Cu plus copper
Cu plus. And the anion which is present here of an acid?
nitrate NO3 1 minus.
Okay. When we are talking about the double salt, the alum, that is the potash alum, the formula, you have to learn these formulas, okay? The potash alum and the more salt, most important. So talking in terms of the potash alum, we have taken we have taken potassium sulfate and aluminium sulfate with 24 molecules of H2O. So how would you justify this alum is an example of a double salt? Why would we classify it as a double salt?
It contains a mixture of two simple salts chemically combined.
In the crystallization form, right?
Crystallize, and it also has water of crystallization, which is bounded loosely toward to the atom, and when we heat
Yeah.
it, it evaporates.
This is the definition of the water of crystallization, right? So, in alum, what are the two simple salts which are present?
Potash alum, which is K2SO4 Al bracket SO4 dot 24 H2O, and then there
No, no,
is
I'm talking about the name. Try to pronounce the name also, like sodium sulfate or potassium sulfate. Write down, tell the answer in these terms.
potassium sulfate, and then there is aluminum sulfate, and which is bounded by 24 molecules of water.
Okay, so talking about the mixed salt, why there is no general methods of formation of the mixed salt? Because it is formed from the radicals or ions. That's why we don't have any general method of formation, right? So bleaching powder. What is the formula for the bleaching powder?
NaKCO3.
No,
No,
no, no,
no.
no. Bleaching powder.
CaOCl Cl.
Or if you
CaOCl.
want. Yeah, if you want, you can write as CaOCl2. That is also correct. But if you want to show as per the book in the bracket, that is also correct. So in the bleaching powder, as you told me that the mixed salt are formed by the two or more basic radical or acidic radical. So in bleaching powder, what are the two negative radicals formed?
Ca is a positive radical and OCl minus is are two negative radicals.
Okay. And also in the case of sodium potassium carbonate, we are getting what? Two basic radical or two acidic radical?
We are getting two basic positive radicals and yes, and two negative radicals.
Only one negative radical, that is CO3 minus.
CO3 minus.
Okay. The complex salt, they are formed by the mixing of the saturated solution of the simple salts. Right. So name or reagent which is used for testing the ammonia gas. What is the name of that reagent?
Potassium mercuric oxide, which is Na bracket Hg4.
Not Na.
Hg.
K2. K2 bracket HgI4, not Na.
Yeah, yes, sorry. K2Hg.
Okay. So what is the name of this potassium mercuric iodide?
Potassium mercuric, potassium mercuric iodide. The name,
Yes.
Nestle's
As a
reagent.
reagent mean. Yeah,
Yeah.
Nestle's reagent. And remember the testing also. It is used to test the ammonia gas. Okay. That testing and all will come towards in the negative in the that organic chemistry. Okay, what are the how it is used to test the reagent. Okay, talking in terms of sodium silver cyanide. So sodium silver cyanide, can you give me one use of this sodium silver cyanide since it is a silver? Any kind
Sodium,
of thing that is coming to your mind?
sodium silver cyanide is used as an electrolyte in electroplating of silver.
Can you just define what is electroplating in simple words? Just an introduction.
A little bit I remember it is the uh, uh, a superior metal is deposited upon the inferior metal. Like if we say there is a iron is something made out of iron. I want to deposit gold on it, so we will use electroplating.
Okay. Yeah, the you have conveyed me the meaning. No problem. That's correct. Whatever you said. Okay. Also, in the case of sodium zincate, what is the formula for the sodium zincate?
Na2ZnO2.
Hmm. And we would be getting one simple ion and one complex ion. So, what is one simple ion we are getting?
The simple ion which we are getting is Na plus Na1 plus, and the complex ion is ZnO2 minus
Minus.
complex.
Okay. The last topic which is there in your book is the not last the of the page, that is the solubility of metallic salt. Since we are talking about the metallic salts, so they all would be including all the active metals like sodium and potassium. They would be taking ammonium salts. So this types of question comes in terms of solubility, like when we have read about the insoluble precipitate like ferric hydroxide or the copper hydroxide. So we learned that we are getting a particular color in the form of precipitate, right? So you have to just take a quick go through towards the insoluble salt, that what kind of they are forming the insoluble salt. Like as you can see, all the hydroxides are forming insoluble salt. So when we consider of the ferric hydroxide, we were getting the reddish brown precipitate. So it is an insoluble salt. Also, when we talked about the copper hydroxide, we were getting blue precipitate. Also, it is an insoluble salt, right? So all the sulfates, chlorides like NaCl, it is soluble. So that's why calling it a soluble salt, right? Like KCl, it is a soluble salt. Okay, so you have to just go through this page, and tomorrow, let me just have tomorrow we can't have test because